Hi guys, let's go ahead and do today's lesson on our next section in Unit 1. So this is huge. This is the experimental rules and guidelines to all experiments, all studies, all the things that happen in medical and pretty much every aspect to determine if one thing's better than the other. How does this work? Is it statistically significant? Do we have evidence? Can we say there's cause and effect? All of those things. So super duper important. So as we go through what we're talking about, the main things that I want you to focus on are this vocabulary and things associated with these two types of studies. Experiments, the full experiment, they have certain qualities. And then the other one is what's called observational study. They have certain ideas and certain qualities, okay? They also play into what you have the right to conclude. Can you do cause and effect? Can you say proof? All those kinds of things. Pretty much in statistics, we never ever say proof. We just say the evidence gives, we have enough evidence to say whatever. All right, so we'll go into that. Also, of course, who can we generalize to, that kind of thing. So you're going to focus on today, as we go through this, learning the vocabulary that we'll be speaking and that you'll have memorized and that you'll use for the experiments and the vocabulary for the observational studies, okay? You're also going to keep in mind, do we have the right to say we have evidence of cause and effect, enough evidence for that, and or just that we have a correlation, a connection, a relationship. We don't have enough evidence to say one thing causes the other. And then, as we have been talking about, can we say, who can we generalize our findings to? And so on. So those are the things you're going to focus on. Now, I had you read two different sets of things. One of them was this first article on the placebo surgery. Huge, so interesting. And I think the results you find are even more interesting. And then, of course, the other one was on the relationship between and the studies on caffeine and skin cancer. All right, so let's take a look at this first one. Now, here I did not have you fill these in, but I want to kind of talk to you about vocabulary as we go through them. Now, if you are a student who is going to get lost in frantically writing all of this information down instead of engaging in learning as we speak what's going on here, don't frantically write down. All of this is written in color on the notes in Canvas on this page. And so, but if it helps you to write things down, then do that. All right, so let's take a look as we go through here. All right, so first we want to talk about who the subjects are in each study. Okay, subjects are same thing as this vocabulary word called experimental units. Subjects are usually, whenever we say they are human or living creatures, we say they're subjects. Experimental units might be things like tomato plants, not necessarily living organisms, okay? But those things are synonymous. Subjects and experimental units. Who is receiving the treatments? Who is receiving the things in the experiment? Okay. So here, in our first one, we were talking about those 180 patients with osteoarthritis of the knee. So those were who our subjects were in our experiment. So treatments, I think maybe you're familiar with what treatments are, but we need to think in terms of explanatory variable and response variable. Okay, so those are huge ideas. So here, they were seeing if the surgery itself had made an impact on their pain level. Okay, so in this case, the treatments that were being assigned were three different kinds of surgeries: debridement, lavage, or a fake placebo surgery. Okay, so it had said that in that thing. Now, that response that they're measuring is, hey, how has the pain been impacted, and the movement in the knee, both of which have some type of subjectivity to it. So keep that in mind, hence why we ended up having to do this placebo situation. Okay, so now, this is just kind of applications. Why do you think people would volunteer for something like this if they don't even know that they're going to get the real treatment? This happens at MD Anderson in Houston, and for cancer treatments. So they may go into a cancer treatment that's a new and experimental drug, and they don't know if they're going to be receiving the placebo or if they're going to be getting the actual active ingredients. Okay, so why might you go into that if you don't know if you're getting the real drug or the placebo whenever maybe you're desperate for a cure, that kind of thing. So these are truly what happens in the real world and impactful. Well, in this case, maybe these are people who are getting free medical care. Maybe these people are getting financial assistance. Maybe they're going to go through this experiment and they'll say later, oh, you got the placebo and we found that the debridement was the best. We'll pay for your getting the debridement now, that kind of thing. So those are the types of things that sometimes are beneficial to the patients. Okay. So I asked you to kind of consider what kind of conclusions happened in the results of this. Okay. So as it's stated in the latter part of the article, it's so crazy. Neither of the intervention groups, so neither the debridement. Okay, so the debridement, remember, that was when they would go in there. On all three of these, they would make little laparoscopic cuts. But the debridement, they would go in there and they would use this tool to kind of clean up the cartilage, maybe shave off any rough edges, that kind of thing. Okay, and then the lavage, they were just going in there and washing out anything. They didn't actually make any of the cleaning of the cartilage. They just maybe flushed out, hence the word lavage, flushed out any of the debris that might be in there. And then, of course, placebo, all they did was just make some slits on the cutting on the skin and made it appear as though they had done a surgery, but they actually did not. So it says, neither of the intervention groups, the debridement or the lavage, reported less pain or better function than the placebo group. Whew. Okay, that right there is huge. I mean, holy cow. What does that mean? Who cares about this? Well, insurance companies, for one. If they're going to pay for this type of a surgery, then it should have results. And if they see that it's not having statistical evidence of a reduction in the pain and a better movement ability, having better movement, then they're not going to be paying for it. Okay? And we don't want people to go through it either. All right. In fact, there were some, and it said in there, in fact, there were some times where patients were better on the placebo group than the debridement and the lavage. And that probably had to do with the invasiveness of the procedure. The placebo healed faster, okay, from just the cuts and everything. All right. Now, who did you think that you could generalize these findings to? Who do you think these results would really be applicable to? So think about that for a second. Okay. I'm thinking maybe people like these type of people who have osteoarthritis of the knee. Okay. So yeah, all the patients of this type, ones who have this kind of osteoarthritis in the knee. So that's important, okay? And so now I want us to talk about the specific types of qualities in this type of study. This is called an experiment, okay, as opposed to an observational study. Now, I'm going to also kind of go back and forth between this page here. This is in the end of your packet, so you might choose to put your hand in there and kind of go back through it, because we want to talk about what's in an experiment, what's in an observational study, what they both have in common, and then what is the difference between them, okay? Compare, contrast map here we have. All right, so we're going to be looking at the observational study. Now, first of all, our experiment. This is a type of study, and in both of these types of studies, we want to compare the results or the responses to 2 or more groups. So it's always comparing something to 2 or more groups. Okay, but let's go back to what we had here. All right, so here comes some definitional information for actual experiments. So here we go. So I've said that already, explanatory variable. So explanatory variable, there's you a hint. So think what is in general explanatory means. Explanatory, okay? Well, if you think mathematically in a function, it's the x variable that you input. It's the thing that we say is the cause. It's explanatory. We think this is explaining the outcome. All right, so explanatory variable we think is explaining. It's that independent variable, the x variable. Okay, and response, that's what comes out. That's the response to that explanatory variable. So that's the outcome. Okay, so the variable, the explanatory is the input, the response is the output. So let's look. Yeah, the outcome or the study, the result you are measuring. So in our case, it was the pain and the how well the knee could move, the movement of the knee. Okay, so that's your dependent variable, your y. All right, you got to keep those straight. Now, what is in general, what's an experimental unit or a subject? Okay, those are the items, living or not, in the study that the study is being performed upon. Who is involved in the study, specifically into that study. Okay, now the treatments, okay? In experiment, the treatments are those explanatory variables. They are something that is being given to the subjects. In fact, one of the qualities of an experiment is that the treatment must be randomly assigned to the subjects. That's huge. In fact, I have a whole song over random assignment versus random selection. And so we'll talk about that. But I'm planting a little seed about that vocabulary, about that random assignment. Now, this isn't major here, so I'm not going to stress this and get you all into this, but there are factors and levels. A factor is what's being administered. Like the patients get a type of medicine. The patients get a type of exercise treatment. So in general, what are they getting? And then those levels would be the amounts or the potencies. So we'll see in some other examples. A factor could be the medicine, and then the levels would be 0 milligrams, 5 milligrams, 10 milligrams, the different levels, okay? Another factor that patients could get, so whenever they're receiving something, that could be a exercise treatment, okay? And then the levels would be 15 minutes of the exercise, 30 minutes of the exercise, the different levels of those. All right, so let's see what else we have for our experiment, and then we're going to go look at that map at the end. Oh, do you know what a control group is? Okay, you always have to have some kind of control or baseline. Now, these may be subjects that get no treatment, but it could also be subjects that get the current one on the market. For example, if I'm testing a new blood pressure medicine and I have people who I know already have high blood pressure, okay? right here, high blood pressure. So I take lisinopril, okay, so for my blood pressure. But they're gonna do an experiment on me with a new medication. We wanna see how's that new medicine. They are not going to tell me to take nothing. That's dangerous. So the control group would be people that continue on their current blood pressure regimen, and then the treatment, so that's one treatment group, is the nothing or the current treatment. And then the experimental treatment would be the other medication that they're wanting to do it. So control is nothing or already existing currently on the market. Okay. And then y'all were really good yesterday about telling me about what you think a placebo is, a fake. Okay, so that placebo is that fake or sham treatment. The key is it needs to look and feel if that's something you see. So that's why in the surgery, it looked and it felt like they went through the whole process of like a fake surgery, okay? And you do not always need a placebo. You do not always need... There goes the dogs. Okay, that was Cookie barking, and then Pumpkin go running after her. Okay, so you do not always need a placebo. So that's one of the things I want us to talk about. When do you need a placebo? Okay, so let's talk about that for a second. If I was just measuring my cholesterol level on drug A and my cholesterol level on drug B, that is a measurement in my blood. That is not something that I can go, ooh, cholesterol get better, cholesterol get better, cholesterol get better. It's not something I can psychologically make better by thinking, ooh, I'm getting the new and improved medicine. My cholesterol must be getting better. Woohoo. Okay, no. You would use a placebo to fake out the person, fake out the subject, if you think that there's a measure of psychological response being measured. Pain, how you feel, energy level, your opinion about the effectiveness of something, okay? So placebo is something to consider if the response you are measuring is a psychological response. If it's just facts, hardcore, non-fakeable, you don't need to have a placebo. Okay, so that's important. All right, now, there's this thing called single blind and double blind. And that has to do with who knows about what medicine they're getting. So if the response is pain and we need to manage who knows about the treatment, then you can either have a single blind or a double blind treatment, experiment, single or double blind experiment. So let's take a look at that. So single blind has to happen first and foremost. Single blind happens if the patient, the one receiving the treatment, the one getting the surgery, doesn't know which treatment they received, okay? The person getting the medicine, maybe one medicine looks like a little white pill, and then the other people, they get one that looks just like it, but it's like a Tic Tac or something, okay? So if the patient doesn't know which treatment they are receiving, but the doctor does, or the person that they're talking to or they're communicating to their results, that person knows, then that's just single blind. All right. But if neither the patient nor the doctor or the psychologist or whoever it is that they are reporting their response to, so if they go to the physical therapist to report their pain in their knee or how much movement they have, that kind of thing. If they're going to the physical therapist and the physical therapist also doesn't know which treatment they're getting, that's called double blind. Now, hey, somebody somewhere knows. I mean, it's like the lab technician has the matching, goes and opens up the vault and can match up the patient number with their treatment so that somewhere somebody knows. You can't just have nobody knowing, okay? But if everyone who interacts with the patient and the patient themselves don't know, then it's double blind. Okay, so I want you to think for a second. Why might double blind also be something to think about having? Okay, so think about that for a second. Why? Well, what if I'm the doctor and I know, or especially if I'm in cahoots with the pharmaceutical company that's doing some things, then I might be coming in and saying, hey, how's it going? How you feeling today? Is it much better? Because I know that you're on the medication that I want to push that will benefit my pharmaceutical company that I have stock in too, okay? So if there could be some interaction where there even is a subconscious interaction that might sway or give hints away to the patient, then we might not want the doctor to know as well. Okay, so there you go. Is that all on that? Yes. Okay, so good job. That is experiment. So flip over to the end of your packet real quick and let's take a look at that. Here we go. Here's our experiment. Okay, so they both experiments and observational studies. Or observational studies are a type of study that compare two or more groups. Okay, now we haven't talked about this one right up here with the generalizing, okay? But here we did this. If you have random assignment, so this is kind of a big idea. If you have random assignment, that's one of the keys to this thing called random assignment right here. If you have random assignment, that allows you to infer cause and effect, and we'll talk about that in a little bit, okay? You have treatments that have been randomly assigned to the subjects, okay? This also is one where it's a prospective study only because you start the experiment and you move forward. That's called, that's called prospective, okay? You only move forward, you start it, and you go forward and watch the results. Now, let's actually talk about a couple of other things that it has on here. This one says the subjects in the experiment are just volunteers, okay? Well, I hope that makes sense to you. So the people in the placebo surgery, they did have to agree to it and volunteer for it because they had to give their consent. Okay, we cannot take somebody and go, I'm forcing you to take this new medicine, or I'm forcing you to stay on the old medicine, or whatever, okay? Because we're people and we can't force them to do the things, at least in America. The experiments are done typically on volunteers. All right, and we'll see that's different with observational studies. So these are things to watch out for with the observational studies. All right, so speaking of observational studies, let's get to that. All right, that's the articles that you read over coffee. And the reason it was mentioned as coffee is because it was referencing caffeine. So you guys have got all the energy drinks. That's where you're getting your caffeine. Well, and coffee too, probably. I get my caffeine from tea. I like to do the hot tea instead of the coffee. But in whatever form you're getting it, the caffeine is what we were seeing is having an impact on skin cancer. All right, so let's kind of take a look at what these studies said. Now, I'm just going to kind of go through this. I don't want us to get hung up on all the details of this, but let's review vocabulary as we go through this. Here we go. All right. Okay, so we had a few different studies who had different subjects in them. Okay, so that was interesting that they were done on different things. So study 1 was just adults. Study 2 was specific this. 3, I think, was about mice, but wasn't really quite clear. Okay, but we had subjects in there. And what happened was we never did random assignment. We never numbered the subjects and said, hey, you take this much caffeine in a day and you can't have any in a day. So it was more just an observation of already existing conditions, people that, especially with the adults, okay? The mice, they might have been able to do that, and that's kind of what PETA doesn't like in environmental, the animal rights people. They don't like that forcing of the things on the animals, okay? So therein lies some issues there. But we were kind of just going with their regular amounts of what they had. Okay. So that's a big deal. That actually is the defining difference between an experiment and an observational study. Huge. In an experiment, we have a controlled environment where we take all the subjects and then we randomly assign. So we have no interest in who these people are. We just do random number generator or put them in a bag, shake well, and pull out half of them to get this, or a third of them to get the debridement, a third of them to get the lavage, and a third of them to get the placebo surgery. So it's called random assignment, okay? In this case, we did not take the people, put them in a bag, shake well, and then randomly pull out half of them to get and force them to do this much caffeine. And then these people, you cannot do any caffeine. We did not force that upon them and randomly assign them to those things, okay? That random assignment is a big idea, which we'll talk about more later because it's such a big idea. But anyway, so what happened here is we just observed already existing conditions. We said, okay, hey, how much caffeine do you take regularly? Yada, yada, yada. You're telling me all the things. And then later, I'm going to observe down the road the response of who got the proportion of people who got skin cancer. Okay, so that's the response that I'm going to be measuring. All right. So does it appear as though coffee or caffeine is the only variable contributing to the reduction of skin cancer? Okay, so that's an interesting thing. I wonder what you thought when you were reading this. Okay, so I put a big old no. There could be other things that are contributing to it. So I want us to talk about this because this plays into what we're going to talk about tomorrow, which is lurking variables. Okay, but let's think. I want you to think about this. Think of one of the major causes. I'll go ahead and say cause. The major known things that contribute to skin cancer is what? What's one of the major things that contribute to your skin cancer, okay? Of course, we all know it's the sun, okay, the exposure to sun. Okay, so let's think about people's caffeine intake. So if people are naturally drinking a lot of caffeine, what are those people generally doing in the day? Okay, I think a lot of times coffee drinkers and caffeine drinkers such as yourself, these are people inside, and they are office workers, they are students, they are in there trying to do a job, and for the most part, an inside job. I honestly don't think, I know even in band and that kind of stuff, if you're going to be doing things outside, they kind of discourage you and don't want you to be all hyped up on the caffeine stuff because it's just not healthy for you when you're doing that strenuous exercise and such outside. So something to keep in mind. Okay, so therefore, let's think about this. People that are inside, not being exposed to the sun, naturally are drinking more caffeine. So, is it the caffeine that's contributing to reduction or less skin cancer rate, lower skin cancer rate? Or is it because they're inside contributing to their lower skin cancer rate? Okay? Huge. So, and the reason that's a big deal is because I am not taking all the people who work outside and who work inside, and I'm putting in a bag, shake well, and I'm randomly assigning them to go to the these much caffeine and randomly assigning to no caffeine. Or I'm even stratifying and saying, I want to make sure I get some inside workers and some outside workers doing caffeine, and I want some inside workers and outside workers doing no caffeine. Okay, that would be random assignment so that we are controlling who gets what. But that didn't happen here. In observational studies, when we observe already existing conditions, we are naturally having other things that could creep in because we did not do a controlled experiment. All right, that's huge. That's the big, big deal. So because of that, we cannot say cause and effect. Other things could be happening. So the best we can do is say that there is a correlation. There's some kind of connection. It appears as though the more caffeine, the lower your skin cancer rate, okay? But I can't say that caffeine is the cause to reduced skin cancer rate. All right, so let's go through some vocabulary. These were just who we could generalize the findings to, and I think you're getting pretty good at that, so here we go. Ready? So, observational studies, there's two kinds. Remember over here on this, there was perspective only for experimental, but for the other one, there's retrospective or prospective. So let's see the difference between those. Those are for the observational studies. So retro, what do you think retro is? Looking back. So if you can retro like in the 50s or whatever you say is retro nowadays, it's probably like the 80s, okay? In my youth, the 50s were retro. Now in y'all's youth, it's the 80s, okay. Looking back on past data. So I'm looking back at past medical records. I'm looking back at past school records. That's a retrospective study. And then I'm seeing if there's a correlation between some things. All right. Prospective. In an experiment, you start the people and you follow them forward. Okay, so that's prospective. Well, in a prospective observational study, it's the same thing. That would be like identify the kindergartners and then follow them forward for like Aledo kindergartners, follow them until they graduate from Aledo High School. So you're just keeping track of ones that stay in Aledo ISD. And then you're going to keep track of the activities they were in and their GPAs, that kind of thing. And maybe we want to see, is there a correlation between the activities they're in and their GPAs? Okay? And we would be doing that with all the kinds of, we would start with kindergartners and follow them forward. Okay, so prospective is following forward. Okay, anecdotal evidence is not scientific. An anecdote in English, have you heard of an anecdote? That's like a story that somebody tells. So that's somebody's personal accounts. That's their recollection. We can't say that's scientific evidence. So that's not necessarily reliable. Okay. I'm going to pause on these definitions of lurking variable and confounding variable because we're going to focus on those two tomorrow. So that's it. All right, so let's flip back to this past map and really study the differences between observational study and experiment. And then I'm going to go into guiding you through the conclusions we can draw. Okay, so here we have observational studies. No cause and effect. We can only do correlation. And that's because we did not have random assignment. The only way to do cause and effect is if you have random assignment to the treatment groups, because when you want to spread unknown traits evenly, you randomize. You randomly assign to spread those traits evenly. Observational studies are interesting. Since they are not invasive and force something on people or subjects, we generally randomly select them from the population. I could just randomly select seniors and see if they were Aledo ISD their whole life and then go look back at their records. So it's not anything invasive where I have to get their permission, where I have to randomly assign them to a treatment. I can just randomly select seniors, and we've had some students in their AP seminar or AP research do that, where they've done a random selection of certain files and then back check those records, okay? So because you do just random selection from the population, if you do random selection from the population, then you can generalize to the population. That is a big benefit of observational study, is if you randomly select from the population, and I even have a song that does this, so we'll do that tomorrow. If your sample's like the population, you can generalize. So if your sample's like the population, then you can generalize to the population. But the big deal with experiment, they were volunteers. They were a certain kind of people. Maybe they were more desperate for a cure. Maybe they were more desperate because their blood pressure was out of control. If that's the case, you can't generalize to all kinds of people who have this cancer. You can't generalize to all kinds of people who have high blood pressure because they are more severe cases, or they're going to be more regimented and follow the protocol of the experiment. You can only generalize to people like the ones in the experiment. Okay, so that's a big deal. Observational study, not stringent, not placed upon the people. So you can just randomly select whoever you want and then generalize to that population. Experiment, more limiting, because you're forcing something upon them. You're forcing a treatment upon them, and so you have to have volunteers, because you got to have their permission, and therefore they might have certain qualities that might limit. They're not like all of the things. Okay? They're more desperate. They're more needy. They're more regimented and more health conscious. Okay? So you can only generalize to people like the volunteers. Huge. All right. And so now let's see. See, the observational study, already existing conditions. You just observe things that already happened or things that are naturally happening. You did not, like over here in the experiment, you did not impose a treatment upon them. Okay? And then here I mentioned we had randomly selected subjects in the observational study, whereas in the experiment, since we have to have their permission to like force something on them, they're usually volunteers. Okay, that's the big deal. This page is so important in kind of spelling out those major similarities and differences. Okay, and then I think on this next page of the notes, I have this, but it kind of does exactly what we just talked about. So let's read it real quickly, and then we're going to pause, and I'm going to do a separate video on the homework in case you run out of time and don't get to that. And then I'll link it, of course, in Canvas so that you could watch the homework explanation if you when you want to, because I'm sure you would want to. Okay, so here, real quickly, let's look. Experiments, they have to be well designed, and we'll talk about the specifics of that, but they must have random assignment. They must have assignment of the treatments to the experimental units. Okay, that's the criteria, that they must have that random assignment. Okay, and then they have this random assignment. And look, this is important. And whenever we listen to our song tomorrow on randomized to reduce bias, actually some of the wording in here is like about this main topic right here. You know, my songs are not just for fun. They have main points, okay? So my song talks about when you want to spread unknown traits evenly, spread all the unknown traits evenly so that the people I make do that treatment are like the people getting that treatment, okay? I didn't just put inside people get that treatment and outside people get that treatment, because then that might be a problem. Have too many variables. Okay, so the goal of randomness is to reduce that bias by spreading unknown traits evenly. All right, this in turn makes the groups similar so that then the only difference is the treatment. All right, what can we conclude? We can do cause and effect. We can, if we have significant results in an experiment because we had random assignment or experiment, yes, cause and effect. Okay, but we're limited. We can only generalize to people like those ones in the experiment, people like those volunteers. All right, And then here, let's do the other ones. Observational study. There are no forced treatments. There was not random assignment to the treatment groups. A lot of times we had a random selection from the population. So I could just randomly select whoever I wanted. And then because I did random selection, I know they're like the population, and that's good. I can then generalize to the population. Okay? But this you have to watch out for. Just because you see a connection, just because you see a correlation, just because it looks like those who have more caffeine have lower rate of skin cancer, doesn't mean that the caffeine causes reduction in skin cancer. There could be something else, like the predominantly being inside or outside type thing. Okay, so therefore you're limited. No cause and effect for observational studies. All right, and again, because you randomly select, you might then have the benefit of generalizing to a bigger population, not just the volunteers. Okay, so there's your summary. No cause and effect, but we might be happier with who we can generalize to because they were randomly selected and they're like the population. Okay, so I'm going to stop this video here, but then I'm going to pick up on how to do the homework. It's like 6 pages of homework, and that sounds like, holy cow, a whole lot, but there's actually just one problem per page. And you first decide, is it an experiment or observational study? And once you decide which one of those it is, you knock off half of the questions on that page. Okay? All right, so I'll see you in the next video so we can see how you do on those differences between the experiment and the observational study.